Hello students, I welcome you all in my lecture videos. So in this video, I'm just going to start with this electrostatic. That is our first topic. Now, if you remember, in mechanics, the basic property was mass. In electromagnetism, the basic property would be the charges. So let's start with the definition of electrostatic. Electrostatic deals with the study of forces, field and potential arising from static charge. Now let's see how charge can be produced. Yes, so that is called the frictional electricity. As you can see in the picture, the glass acquired positive charge and the silk acquired negative charge. It's because when we rub two bodies like that of the one which is shown here, there the electrons in the glass are loosely bound in it than the electrons in silk. So when the glass and silk are rubbed together, then loosely bound electrons from the glass gets transferred to the silk. Now it is very important to note that the electrification of a body, whether it is a positive or a negative, is due to the transfer of electrons from one body to the another. That is, if the electrons are transferred from a body, then the deficiency of electrons makes the body positive. But if the electrons are gained by a body, then the excess of electrons makes the body negative. So, after years of efforts and careful experiments and analysis, it was concluded that there were only two kinds of charges, that is electrical charges, that is positive and negative. As you can see, the charges were named as positive and negative by the American scientist Benjamin Franklin. We know that when we add a positive number to a negative number of the same magnitude, the sum is zero. This might have been the philosophy in making the charges as positive and negative. So by convention, the charge on a glass rod or cat's fur is called positive, and that on plastic rod or silk is termed as negative. If an object possesses an electric charge, it is said to be electrified or charged. But when it has no charges, it is said to be electrically neutral. Hence, the total charge or net charge Q is equal to 0. Here is a video, you can just take a look. It's about the electrical charges and the productions. Now, so all of us very familiar with such a kind of our childhood experiment, while we can see that the comb attracts the bits of paper when we rub. Now you see again, as the comb is rubbing, we're just combing our hair, then it attracts the bits of paper. So now it is charged. So for any child, it may be a matter of scare that, yeah, now it is charged, so it may be dangerous. Any object have got some positive and negative charges. But the safe and the most interesting thing is that in nature it is in balanced state. So any object which is positively and negatively charged in equal amount, it is said to be balanced, or hence it is a neutral. So there is nothing to worry about our surrounding objects. Now I'm going to take the plastic comb and just try to perform the same experiment as before. But now, as you can see, it is electrically neutral. That is, the number of positive charge and the negative charge is same. Now if you perform the same thing, just rubbing the paper with this comb, it will not do any magic. Yes, here something is missing. Once it is rubbed with hair, now it is electrically charged and it can attract the papers very small pieces of paper, like not like the one which is shown in the video. Now if you replace the plastic comb with a metallic comb, do you expect the same result? No. Now why? Let's explore. Now let's take a look again to the plastic comb. As we all know, it is not a good conductor of electricity, so it is not allowing electricity to pass through them. Now it stored the charges. Now it is electrically charged. Now it will attract the bits of paper. Now if you replace with the same metallic comb, now if you charge will generate, but it will pass. It will not store. Now there will be no magic here. So from the properties, as we can see, there is a positive charge and a positive charge. So if you bring two charged body where the charge are of the same pattern or same type, then they will repel. In the case of negative charge also, if you bring two negatively charged objects together, it will repel. But in case of the oppositely charged objects, they will attract. Next comes the additive nature of the charges. Here you can see this oval shaped object. Also there are some Q1, Q2 and Q3 charges are there which are not added to this particular object. So before adding the net charge of the system, that is Q is equal to 0, because the number of positive charge and the number of negative charge are same. So hence it is electrically neutral. But once you add those things, it will be something like the net charge will be Q is equal to Q1, Q2, Q3. That is the sum of all the charges. Next thing is the quantization. So in very simple, say this is the first case where this is a classical picture that we can take any point. We can expect if someone wants to climb, so he can take 0, 0.5, even 0.2, 0.1, anything. But on the next right panel, as you can see here, it is 0, 1. So these are 1, then it will come 2, 3 and so on. So this what we call the quantization, that is, it is in discrete, it is not continuous. So all possible charges in the universe are in the form of this n into E, where E is the elementary charge, which is 1.6 into 10 to the power minus 19 coulomb. So now in short we can say that, say in elementary charge, which is 1.6 10 to the power minus 19 coulomb, we cannot break this charge further. Say we cannot get a value of a charge which is 0.8 into 10 to the power minus 19 coulomb. Now the charge conservation, as you can see, this is a piece of rod which is having a charge minus 4e. Now it is just going to, I'm just going to touch with a metal ball. Before charging, it is having a net charge Q is equal to 0. So once I make a physical contact with the spherical object, as you can see in the picture, so after the touch or the contact, you see here it is now having Q is equal to minus 2, and here also Q is equal to minus 2. So it is distributed 2 electrons to the spherical objects. But before touching, if you just trying to calculate the sum total of the charges, so that is minus 4, and also after charging, if you sum them up, this stick with the ball, spherical object, he will find it is same. So hence we can say the charge is conserved. So up to this, next the upcoming lecture will be in the Coulomb's law. For any doubt, please contact with me in this number, and thanks for watching the video.